Hello dear students. So the next relationship in the graph is connectivity. A graph is connected if every node can reach every other node. Example, every student in a class can communicate with every other student. So the graph is connected if there exists a path between any pair of nodes. So the connected can be classified into strongly connected and weakly connected. Strongly connected in the sense there exists a directed path between any pair of nodes. Weakly connected in the means so there is no direct connection, and a graph is disconnected. It means some students have no connection. This one is the disconnected. So these are the examples of type connected graph. So there is a direct edge from each node, and disconnected means some of the nodes will be disconnected from the graph, and strongly connected in the sense every node reaches every other node using arrow directions, and the weakly connected is if we ignore the direction all nodes becomes connected. This one is the weakly connected. So the next one is component. Sometimes graphs split into groups. Each connected group is called a component. Imagine college clubs, sports club, music club, coding club. So each forms its own connected component. In connected also we are having strongly connected and weakly connected. So these are the components and these are the strongly connected. So the next one is the shortest path. Suppose you travel from Pollachi to Chennai, there may be many routes. Which one is best? The shortest path minimizes distance, cost or travel time. Google Maps, network routing, airline systems, robot navigations, all these applications will use the shortest path algorithms. Uh, Example for the shortest path algorithm is Dijistra's algorithm. So the next one is the diameter. So diameter tells us how large a graph is. It is the longest among all shortest paths. Social networks usually have surprisingly small diameters. This leads to the famous 6 degrees of separation. So meaning that almost any two people in the world are connected through about 6 people. So the next one is the trees. Next type of graph is the special graphs, which are the trees and graphs. A tree has no cycles, exactly one path between every pair of nodes. So the examples of tree are family tree, folder structure, company organization chart. A collection of disconnected trees are called as forest. In a tree, the number of vertices equal to number of edges plus 1. So the next type of special subgraph is spanning tree. A spanning tree connects every node using the minimum number of edges and then without creating the cycles. If the graph has weights, we prefer the minimum spanning tree. So the applications of minimum spanning trees are electricity distribution, road construction, internet cabling, water pipelines, and then the algorithms used for MST are Primson-Kruskal's algorithm. So the next type of tree is trainer trees. Sometimes we don't need to connect every node, only important locations. Example, connecting only hospitals or only bank branches, so that the Steiner tree minimizes total cost while connecting selected nodes. So the thick line represents the Steiner tree structure. So the next one is the complete graph. In a complete graph, every node connects to every other node. Suppose 5 students all know each other. Every possible friendship exists. This forms a complete graph. For example, we are having 3 nodes V1, V2, V3. So V1 is connected to V2, V3, and V3 is also connected to V1, V2. Likewise, the complete graph exists. So the next one is planar graphs. So planar graph can be drawn without edge crossings. So the road maps are usually planar. Electrical circuit layouts also prefer planar graphs. Some graphs cannot avoid crossings. These are non-planar. So the next one is bipartite graph. So bipartite graphs contain two different groups. So the edges connect only between groups. Example, students groups to courses, doctors to patients, employees to companies, movies to actors. No connections exist within the same group. So the next one is affiliation networks. An affiliation network is a bipartite graph. Example, people belong to companies, students belong to clubs, teachers belong to departments, edges represent membership. This is the bipartite or affiliation graph. So the next one is the, it shows the left side is the some a group of companies and the right side is the some group of branch. It means affiliation of people on corporate boards of director, peoples and companies. Okay, so the next one is, regular graph. A regular graph is one in which all nodes have same degree. Every node has the same degree. Suppose every student has exactly 3 friends, then the graph is called 3 regular. And then egocentric network. An egocentric network focuses on one person. That person is called the ego. The connected people are called alters. Example, teacher and students, doctor and patients, mother and children. This type of analysis is useful in psychology, healthcare, education and social behavior studies. So the next one is bridges, cut edges. A bridge is a very important edge. If we remove it, the graph becomes disconnected. Example, a bridge connecting two islands. If it collapses, travel becomes impossible. In computer networks, bridge links are critical because failure disconnects communication. Identifying bridges helps improve network reliability. So, by concluding the session, we explored a wide variety of graph concepts, including null and empty graphs, directed, undirected, and mixed graphs, simple and multi-graphs, weighted, signed, and web graphs, and then walks, trials, paths, connectivities, and different types of trees. So these graph types form the foundation for advanced topics such as graph algorithms, centrality measures, community detection, shortest path algorithms, and network analysis, which we will learn in the upcoming sessions. So thank you, students.